All right, welcome to our video for the notes for 7.2, the second section in Unit 7. If you're watching this video during class on Tuesday, February 28th, when Werner is out on jury duty, then this is a reminder that you should make sure that you finished 7.1 first and checked your answers. The answer key is posted on Schoology. It's also on the wall in the classroom. Make sure you check your notes there first. But for the second section, where we are solving proportions, I'm going to take you through it in this video a lot like I would during class. I'd encourage you to pause the video or go back and rewatch something if it was confusing. Use those features to your advantage. I'll also, I think, try and put in timestamps for chapters in this video so that you can skip ahead like after you finish the notes if you want to do the practice on your own and then check your answers on the paper instead of watching the video. That is perfectly fine as well. All right, putting my name up here because I always put my name up here. The date that we're doing this in class, February 28th, 2023. All right, two little blurbs of notes before we get started. A proportion is an equation where two fractions are equal to each other. Proportions is really the important thing that we're doing this unit. And so the reason we spent the whole first day doing fractions was because proportions involve fractions. For example, this little guy right here, 1/2 is equal to 3/6. That's a proportion. Second piece of notes is about a ratio. You hear ratios come up a lot when you're talking about fractions, and that's because a ratio is mathematically the exact same thing as a fraction. There are some slight differences with where they come up. Like fractions are usually talking about a part of a whole, whereas ratios can compare two completely different things. But when you're doing math with them, you're setting up equations, it's going to be the exact same thing. So for our purposes, a ratio is just another word for a fraction. The only reason I'm mentioning that is because some word problems will have the word ratio, and you should just know, oh, that just means fraction. So for example, the ratio 3 and then the little colon here, 5, is the same thing as 3/5 as a fraction. You see this a lot in like recipes or like mixing ingredients. It'll be written with that little colon there instead of as a fraction. Same thing. Okay, first practice section, determine whether the two fractions form a proportion. Hint, reduce both fractions. So a proportion from back up here, they're equal to each other. So basically we want to figure out if these two fractions down here are equal to each other. Well, they have different numerators and denominators, but if they're the same, we should be able to make it so that the fraction on the left matches the fraction on the right. We can do that by reducing both of our fractions as much as possible. So some good practice from what we did yesterday, where we're trying to make these into the simplest fractions we can. I'm going to zoom in on this. Uh-oh, screen is on the fritz. Never mind, that was a bad idea. Uh-oh. Okay, hopefully you got the notes from the top there. Hang with me with these technical difficulties. Okay, so first problem, we have 5/3 and 35/21. You might know that 5 and 3 can't reduce those at all. Both of those are prime numbers, so that's as simple as it's going to get. On the right-hand side, though, we can find our greatest common factor. So the biggest number that we could divide both of those numbers by, and maybe it pops out to you that you could divide both by 7. Greatest common factor is 7. So if we divide the top by 7, divide the bottom by 7, we get 35 divided by 7, which is 5, and 21 divided by 7, which is 3. And oh, look at that. This first fraction and this fraction here are the same. So our answer is yes, this forms a proportion. So your answer for each of these questions will be yes, it forms a proportion, or no, it doesn't form a proportion. If this makes sense to you, of course, feel free to skip ahead and just check your answers. If not, Stick around, we'll do the problems together. Make sure you are trying them though and making sense of them. If you just copy down what I write, it's probably not going to help you learn very much. Problem number 2, we have 9 over 24 and 24 over 64. So I think we can reduce both of these. On the left, we should figure out what the greatest common factor is, or something that we could divide both of these numbers by. If you don't remember how to find the greatest common factor, you can look at your notes from yesterday on 7.1, where we found greatest common factors and we practiced reducing fractions. I can tell though that we can divide the top by 3. We can also divide the bottom by 3. So if we divide the top by 3, we get 9 divided by 3, which is 3, and 24 divided by 3 on the bottom, that's 8. So the first fraction reduced would be 3 over 8. The second fraction, well, they're both even numbers, so I'm going to start by just dividing by 2 on top and bottom. Divide by 2, divide by 2, and we get 12 over 32. Both of those are also even numbers, so I'm going to divide by 2 again. Divide by 2 over divide by 2. Then we get 6 over 32 divided by 2 is 16. Oh boy, this one's taking us the long way. Divide by 2 again, and we get 3 over 8. And would you look at that? This fraction here matches this fraction here. Took us a couple steps, but yes, this forms a proportion. I might not have given you lots of space here. Sorry about that. Also, general disclaimer, of course, as with all of my math work and my answer keys, is I tend to make lots of silly mistakes when I do these problems. It's totally possible that you will find a silly mistake in my work in this video or in the answer key. If that's the case, put a star next to it. Tell me about it on Wednesday. I look forward to all of you telling me about my mistakes. I'm sure that there's going to be one. Number 3, 8 divided by 56 and 6 divided by 28. Well, these guys, I notice we can divide both of them by 8. Divide the top by 8, divide the bottom by 8. That gives us 1 over 56 divided by 8 is 7. Let me double check that on my calculator. Perfect, yes. 56 divided by 8 is 7. So that fraction reduces to 1 over 7. On this side, nothing stands out to me immediately. But I do know they're both even numbers, so I can always divide by 2. Divide by 2. So then I get 3 over 14. 3 is a prime number, so I can't reduce this fraction anymore. So these are our two fractions, 3 over 14 and 1 over 7. Because they're different fractions, that means no, they do not form a proportion. They only form a proportion if those two fractions are equal to each other. If I'm moving too quickly for you while we're working on these problems, you should pause, take a minute, see if you can work through the problem, come back if you need some help on it. Speaking of which, pause the video right now. You, who's just copying down what I'm writing, pause the video, take a deep breath, turn your brain on, see if you can do the next 3 problems. It's the same exact process. You're going to reduce the fractions and see if they're the same. Check your answers and come back if you need to work through any of them. If you're here, that means you've tried the problem and you need some help on it. That's okay. That's what I'm here for. But don't just be here listening while you copy down the answers. There's some of you who I know that that's what you're doing, but do better. Use some math brain. It'll help you out in the future. Okay. 18 over 4. There's nothing that really stands out to me Nothing that pops out as a GCF up here. So I'm just going to divide by 2. Divide by 2. Divide by 2. That gets me 18 divided by 2 is 9. Over 4 divided by 2 is 2. So I have 9 divided by 2. That can't be reduced anymore. So that's my fraction there. For this one, the second fraction, 27 over 9, that stands out to me, that both of those are divisible by 9. So I'm going to divide by 9 on top, divide by 9 on the bottom. 27 divided by 9 on top leaves us the 3. 9 divided by 9 is 1. So those are our two fractions. 9 over 2, 3 over 1. They are not the same, so no, it is not a proportion. Number 5, 15 divided by 21. This one's a little trickier. They're not both even, so we can't divide by 2. What about, would 3 work? Kind of narrating what my thought process is when I'm reducing fractions. And yeah, both of those are divisible by 3. Divide by 3. Divide by 3. 15 divided by 3 is 5. On top of 21 divided by 3, that leaves us with 7. So that's the same as 5 over 7. This one, those both look like they're divisible by 11. Divide by 11. Divide by 11. By the way, maybe you figured this out already. Oh, good Lord. Very glitchy screen. You don't need to write this out necessarily, what you divided by, but I do find it really helpful when I'm making silly mistakes and needing to check my work again. It makes it a lot easier for me to remember where my mistakes were or to figure out where they were in the first place. 55 divided by 77. Okay, we're going to divide the top by 11. That leaves us with 5. Divide the bottom by 11. That leaves us with 7. Looky there, our fractions match up. So yes, this is a proportion. Last one. Hopefully you're feeling good about these by now, and hopefully you've tried this on your own. These two, I'm just going to divide by 2. Divide by 2. Divide by 2. Sorry, I've made it pretty squished in this section, so sorry if you're running out of room. My bad. 26 divided by 2 is 13. 8 divided by 2 is 4. 13 is a prime number, meaning we can't divide it by anything else. So that has to be our final reduced fraction. And then the other one, I think 39 is divisible by 3. And 12 is divisible by 3. So if I divide by 3, divide by 3. 39 divided by 3 is, nope, not 12. 13 over 12 divided by 3. That's 4. Nice. We got the same fraction for both. There you go. So those are your answers to the practice problems, or the first section of practice problems. Trying to fix the blur. There we go. Make that a little bigger. Number 1, yes. Number 2, yes. Number 3, no. Number 4, no. Number 5, yes. Number 6, yes. Oops, I highlighted the wrong thing. Yes. Awesome. You might be thinking, surely there must be an easier way to do that. That was so much work for such a simple answer. And you are right, there is an easier way to do it. Maybe some of you jumped to this when we were doing the last section. It is called finding the cross product. Cross product is pretty easy because it is what it sounds like. Cross, like you make a cross, and a product means to multiply. So let's take a look over here in our notes section. To find the cross product, multiply the opposite numerator and denominators together. So if I zoom into this section here, it means multiply this numerator and this denominator. And in another color, we'll do this numerator with this denominator. That's what we're multiplying. And then we'll write that down below. So in pink on the left, we're multiplying 2 times 15. So fill in the blanks. 2 times 15. On the other side, we have 5 times 16. Sorry, not 16, just 6. On the left, 2 times 15 turns to 30. On the right, 5 times 6 turns to 30. Look at that. So the second line of notes over here, in a proportion, the cross products will be equal. So instead of reducing fractions, you could just do the cross product. If you get the same number here as you do here, then you know that it's a proportion. If you really wanted to, for some extra practice, you could go back up to the top and redo this practice section here with the cross products, and you should get the same answers. All right. See if you can do this practice section on your own with these first 3 problems. You're just showing that the cross products are equal. So write down what the cross product is, punch it into your calculator, and show that you get the same numbers. I think it's good practice to remember what you're doing here. If you need help doing that, stick around for a minute. We'll do them together. So first cross product here is going to be 7 times 18. I'm going to write it out just because it's helpful to show what we're actually doing. So 7 times 18, that should be equal to this guy, which is 21 times 6. I'm going to type that into my calculator because you certainly do not need to do that in your head. 7 times 18, my calculator tells me is 126. And then on the other side, we have 21 times 6. Look at that. 126 equals 126. Perfect. This is, in fact, a proportion. All of these are proportions, so all of these should be true. Or all of these should get the same number on the left and the right. Number 2, doing the same thing. 5 times 12 is equal to 6 times 10. Punch in 5 times 12 on my calculator. It tells me that's 60. That is equal to 6 times 10, which is 60. Perfect. And then the last one, same deal. 3 times 180. 3 times 180 should be equal to 9 times 60. Type into my calculator. 3 times 180, 540, is equal to 9 times 60, which is, oh look, 540. Perfect. If you didn't get those answers somewhere, probably just typed it into your calculator wrong. For the next little practice section, we're now missing a part of each one of these equations. So instead of having all 4 numbers, we have some x's in here, or some variables. The good news is we can use the cross product to write an equation, and then we can use algebra to solve for the answer. Zooming into the first one, we got to find the cross product first. I'm going to write it out just like I did in the problem up above. So the first one is 7 times 10. On the other side, we have 5 times x equals 5 times x. Our next step is to simplify a little bit. 7 times 10 we can rewrite as 70 is equal to 5x. That's the same thing as 5 times x. When we're solving for x, we're always trying to get x over here by itself. So in order to do that, to get this by itself, we need to cancel out this guy. The opposite of multiplying by 5 would be dividing by 5. So I'm going to divide by 5 on this side. And we have to do the same thing on the other side. Draw a line there to remember these are two different sides. 70 divided by 5. I'm going to type that on my calculator. 70 divided by 5 is 14. On this side, our 5's cancel out. So we get x equals 14. That's our final answer. Problem number 5. Try this one on your own. Stick around if you need help. Here's our first part of the cross product. So x times 3. Our second part is over here. Equals 4 times 9. X times 3. I'm going to rewrite it as 3 times x, or 3x, just because that's how we normally write it. But there's nothing wrong with writing x times 3. Equals 4 times 9, which is 36. In order to get x by itself here, we need to cancel out the 3 in front. To cancel out a 3 multiplied by something, we need to do the opposite. So we need to divide by 3. Divide by 3. On the left, our 3's cancel out, and we're left with an x. On the right, 36 divided by 3 gets you 12. So we have x equals 12. Finally, for number 6, last one, same deal. 11 times 4 is equal to 22 times x, or x times 22. 11 times 4 is 44, equals 22x. To cancel out the 22 times something, we need to divide. Divide by 22. Divide by 22. We get an x by itself. The 22's cancel out. 44 divided by 22 is just 2. X equals 2. So your final answers for 4, 5, and 6, we got x equals 14, x equals 12, and x equals 2. Nice. These ones were just kind of boring problems where we had random numbers and I told you to solve for x. The reason this is helpful is because a lot of word problems are set up this way, and we're going to use it to prove some facts about shapes later on in this unit. Let's do some word problems first, though. If you're feeling good about word problems and you want to tackle them on your own, go ahead and skip this part of the video and you can just check your answers. I'll be here though. We're going to do them together. You know the drill. Number 1, a medicine for dogs says you should give 1 pill for every 15 pounds it weighs. D. Tomaso's dog weighs 60 pounds. How many pills should she give it? Use the proportion below to solve for x. So on the left side here, okay. On the left side here, this is the information that they gave us. This is a ratio or a fraction that they told us. The pill bottle told you that. So it says 1 pill for every 15 pounds. That's our kind of known information, or the fact that we're using to set this equation up. On the other side, we're using the situation that we have, or the one that we don't know as much about. We know one piece of it, which is that the dog weighs 60 pounds. We don't know how many pills it should get, so that's why we put a variable up here. I like putting the units in here, so like I wrote 1 pill and 15 pounds. Some of you might just write 1 and 15, But I like writing these units because it makes it really clear to me that I didn't accidentally flip my fractions over. That's going to be a common mistake in this problem or in these kinds of problems. Somebody might write 1 over 15 equals 60 over x. That will get you a completely different answer, and it's not going to be the correct answer. So I think it's really helpful if you've got a word problem, tack the units on there. That will help you make sure that you've got the right things on top and the right things on bottom. Another question before we even start this is, well, how come I can't do 15 pounds over 1 pill equal to 60 pounds over x pills? That's an excellent question. The answer is that you should try and solve it that way. Try and solve it this first way with pills over pounds. Try and solve it this second way with pounds over pills. If you do that, you should get the same answer for both of them. So yes, this is totally valid. It's just a flipped version of what I wrote. Okay, I'm gonna move this out of the way just so I have some room to work. This is the exact same now as the problems we did on the last page. We're gonna find the cross product, and then we are going to solve for x. So finding our cross product, here are two numbers, we need to multiply them. 1 times 60, that will be equal to this cross product, 15 times x, or 15x. 1 times 60, of course, is just 60, equals 15 times x, or in other words, 15x. To get the x by itself, we need to divide by 15. And we have to do the same thing on the other side. When we divide by 15, these will cancel out. So we'll have an x here equals 60 divided by 15, which is 4. So our final answer is that x equals 4. If she wants to give her dog pills based on this correct proportion, she should give her dog 4 pills. Hopefully this is showing you how these are good examples of real-world situations. There are lots and lots of kinds of problems, like unit conversions, that come up with proportions. We're going to do some of those. Number 2, Mr. Hurst's class is making bags out of fabric. They can make 3 bags out of 2 yards of fabric. How many yards of fabric do they need in order to make 27 bags? So, super practical problem. You're buying fabric for your class. How much do you need in order to make a project for everyone? Use the proportion below to solve for x. On the left, this is the information that we know, like the stuff that they had from the get-go. They know that they can make 3 bags out of 2 yards of fabric. So 3 bags over 2 yards. This is the side we're trying to figure things out about. If they want to make 27 bags, how many yards of fabric will they need? We're going to solve this using the cross product. So 3 times x on our first side is equal to this cross product, or this part of the cross product, 2 yards times 27. So 2 times 27. I'm going to punch that into my calculator. 2 times 27 is 54. So we have 3x equals 54. To cancel out the 3 so that we just have x, we need to divide by 3 on both sides. That leaves us with just an x is equal to 54 divided by 3 on my calculator. That's 18. So in order to make 27 bags, you need 18 yards of fabric. Number 3, Miss Goldman needs chemicals for her labs. Each reaction needs 12 grams of chemical. She has 156 grams of chemical. How many reactions can she run? Write a proportion, then solve for x. So in the examples we did above, I said on the left, we should put the stuff that we know about, like the information that was given to us, like by the experiment or by the bottle of pills. So that's this sentence here. Each reaction needs 12 grams of chemical. So I'm going to write that as the first part of my proportion. One reaction, 12 grams of chemical. On the other side, this is where we're trying to figure something out about the situation. So we don't know how many reactions. That's what we're looking for. So I'm going to put in X reactions over 156 grams of chemical is how much she has. 156 grams chemical. So 1 over 12 equals X over 156. You know the drill. We're doing a cross product. 1 times 156 is 156. That's equal to this side, 12 times X. Now we have our equation that has an X in it. We need to get X by itself. So I'm going to divide by 12. Divide by 12. We get X is equal to, type this into my calculator. 156 divided by 12 is 13. Number 4. Miss Toki is dyeing her hair. The instructions say to mix developer and dye in a 1:6 ratio. If she has 40 milliliters of developer, how much dye should she add? Write a proportion and then solve for X. On the left, we're going to write down a fraction for what the instructions tell us. So they say 1:6 ratio. So it says developer and dye. So that's the same order that it shows up in the ratio. 1 part of developer and 6 parts of dye. So 1 developer over 6 dye. On the right-hand side, we're putting in what we don't know about. She has 40 milliliters of developer, and we're trying to figure out how much dye. So I'm going to make that X dye. Perfect. Now we can cross multiply or form our cross product. Here's one piece of it, 1 developer times X. That's just X. Then going this way, 6 times 40 is 240. And that's our whole answer. Pretty easy on that one. One step. X equals 240. Number 5. Mr. Alvarado is making a tiny cake for his dog. A normal cake recipe uses 300 grams of water and 340 grams of cake mix. He only wants to use 50 grams of cake mix for his tiny cake. How much water should he add? So on the left side, we're going to do what the problem gives us, or like what the box gives us as the ratio. So that's 300 grams of water and 340 grams of cake mix. 300 grams of water over 340 grams. I'm just going to write mix. On the right-hand side, the situation that we don't really know about. We don't know how much water, so I'm going to make that a variable X. X water over, then we do know how much cake mix, 50 grams of cake mix. Perfect. Now we can form our cross product. 300 times 50 is equal to the other side here, 340x. Let's clean this up a little bit by doing 300 times 50, which is 15000 is equal to 340x. Now, to get the x by itself, we need to divide by 340. I have a feeling we are not going to get a whole number as our answer, and that's totally fine because the real world does not operate in whole numbers. 15000 divided by 340. Hit it on your calculator, and I get x equals 44.1-ish. So he needs 44.1-ish grams of water. I rounded there since it's a long decimal. Number 6, maybe you're calculating things about money. You can use proportions there too. Mr. Boland's students got hired for an internship. They make $26 for every 3 articles that they write. A student needs $250 for some cool sneakers. How many articles do they need to write? On the left side, let's write down what we know about the situation. The job description, or whatever it is, tells them that they're going to make $26 for every 3 articles. 3 articles. On the right-hand side, the situation that we don't really know about. We want to know how many articles, so X articles, so that they can make $250. 250 on top. Perfect. Now we can do our cross product. We're going to multiply these two. 26 times X is equal to this down here, which is 3 times 250. If we clean that up a little bit, we get 26x equals 750. Then, to get x by itself, we need to divide by 26. So 750 divided by 26, you get x equals 28.8 articles. You could stop here and say that that's your final answer, but there's a little bit more to it. This is why word problems are fun and fascinating. Does it make sense for somebody to write 0.8 of an article? If you had a job writing articles and you wrote 0.8 of an article and tried to submit that, your boss would probably say, no, you have to finish that in order to get paid anything for it. So 28.8 as an answer for the number of articles doesn't really make sense. We should definitely at least round up to 29. But then, here's the other catch. They make money for every 3 articles that they write. So it sounds like they have to come in batches of 3s. So we need to round up even more than that to make sure that they make their $250. 29 is not divisible by 3. So they're kind of in the middle of a set of articles here. So if they need to do it in sets of 3 articles, they need to write at least 30 articles. That would be my final answer. They need to write 30 articles to make sure that they make $250. If it doesn't super make sense to you why we needed to round up, don't worry about that too much. The important part is being able to solve the proportion. Number 7, Miss Shaw is going to visit Japan. The current conversion rate is 1,365 Japanese yen for 10 US dollars. She wants to exchange 175 US dollars for Japanese yen. How much yen would she get? First things first, let's write down what we know on the left. 1,300 65 yen over 10, I'm just going to write USD. That's our left side. On the right side, we're going to write down what we don't know, or the situation we don't really know about. On top, we know that it needs to be yen, but we don't know how many, so I'm going to write X yen. On bottom, 175 US dollars is how much she's exchanging. To solve this, we should make the cross product, which is multiplying these two guys together. Definitely do that on your calculator. 1365 times 175. Ooh, that's an ugly number. 238,875 is equal to, then our other side of the cross product is this guy, 10 times x. Nice. To get x by itself, we need to divide by 10 and divide by 10. These cancel out, and we're left with an x. And that's equal to 23887.5. So if we figure out where our comma should go, it's right about there. So she would need 23,887.5 yen. That would be equivalent to 175 US dollars. Last problem. Mr. Miller is diluting an insecticide for his garden. The bottle says to use a 1:64 ratio of insecticide to water. This is actually based on the container of insecticide I have sitting right next to me now. And Mr. Miller, I do know, has a garden in his backyard. He wants to use 1,000 milliliters of water. How much insecticide should he add? So we'll start with the situation we know about, which is that the bottle says 1 part of insecticide. If you don't know what insecticide is, it is a chemical that kills insects. Sometimes they're really bad for the environment, so you should do some research before you use them. Divided by 64 parts of water. Sometimes they'll come really concentrated so that you can get a tiny bottle instead of a really big bottle, but then you have to add water to it before you use it. If you don't dilute it properly and you can't do math like this, you might end up killing all of your plants. I have done that in the past. I think I would not be the only one who hasn't. All right, on the left, 1/64 equal to the other situation, or the situation we don't really know about, X parts of insecticide over 1,000 milliliters of water. Cross multiply, form our cross product. 1 times 1,000 is 1,000. On the other side, 64 times x is 64x. To get x by itself, we should divide by 64 on both sides. Cross these guys out. X is equal to, type it on my calculator, 1,000 divided by 64. And you get 15.6-ish. So you would need to add 15.6-ish milliliters of insecticide to 1,000 milliliters of water for it to be diluted properly. Going over all of the answers here on the back page. Oh boy. There we go. Number 1, we got x equals 4. Number 2, x equals 18. Number 3, x equals 13. Number 4, x equals 240. Number 5, x equals 44.1. Number 6, x equals 28.8, but really the answer should be 30 because it's a word problem. Number 7, x equals 23,887.5. And number 8, x equals 15.6. Congratulations! Feel free to go back and rewatch parts of this video if you didn't understand, or know that it's here for the future. If you made it this far, it probably means that the video was helpful to you, in which case, let me know, because I might think about recording videos like this in the future so that you've got something to listen to if you missed a day in class, or if you just need to revisit parts of the notes and want someone to explain it to you. So let me know how the video went for you, and I'll see you later. Bye.